All right. Let's see if this is working. Testing 1, 2, 3. All right, I think that sounds good. So I have music playing on Spotify. And what I wanted to do with the stream was add a little play thing on my stream, so it shows what song I'm currently playing. So what I was looking at was the API for Spotify, and you can get playback state. You can also get what song is currently playing. So I wanted to try to see if I could combine those together. But yeah, and if you wanted to, I'll hang out in the stream room. It says what song I'm currently playing. I think I can. Oh my gosh. Yeah, invite people. There you go. Join the jams. Cool. Cool. So if you wanted to hop in voice, talk to me, that's an option. Let's see. User scoop, chat, play by state, available. Spotify. There we go. Yeah, I really like the Spotify's API thing here. You can just say, request the token, grab it, give it a try. Yeah, so what I was trying to do was use ChatGPT to literally go from like, given a zoom in. It's too far in. Given a curl request, that looks like and an API response that looks like this guy. Write me a JavaScript function that calls the API and gets the current song name and artists. Let's see. Let's see if it gets it. Oh. Come on. I know you can do it. And put it at the top. All right. here's a curl request and response that perform these actions. We'll get rid of the pot at the end. Let's go. Let's go. Yep, got the key. Uh-oh. Oh, no, that's all right. Let's go. Let's go. All right, so I have a this like index. I really should make a folder here that's like stream, make dir projects, stream. I think this is, yeah, currently my background is this index.html file, so I'm not going to move it yet. I'll copy it, index to projects, stream. We'll go into the script, paste the function in. And then we'll have a h1's tag. Color white. ID is equal to song document get element by ID. Document get element by ID, yes. Song dot enter or dot text, I think we do, is equal to get current song. I'll say this. Const song is equal to get current song. Song dot name plus a space. I'll do hyphen plus space. And then song dot artists. Go to 8,000. Nope. Didn't like something. Oh, I didn't await the call. Is that kosher? You have to do that freaking stupid thing. What is it? It's like this, async. This is so annoying. I'm not going to edit it with the terminal. We're opening it up. File, open, stream index. Async. Sure. Projects, stream, start a server, close that out. Refresh. Currently playing. I made the color white. We should just make it black. Or there you go. I don't see anything. Got the response. What up? hit it. Song has the song. Okay. I don't know how to do JavaScript. Write me JavaScript code. I'll do this. Write me HTML that creates a header that is set to the output of the function when the set to the name of the song and artist. I think that should work, right? Nope. Given the after calling the function above. Get song info. Okay, that's not very helpful. Thank you. Let's do inner HTML though. Oh, inner text. Is that the one? Let's go. Undefined. Screw you. I know you're not undefined. Oh, it's song name. Name. So what I wanted to do is put this in a loop. Oh my goodness. There you go. So now if I put this in a loop, write me a JavaScript function that runs in a loop and sleeps for 5 seconds. Really? Do you really call it recursively? This is what I want. It's a good question though. I don't really know that much about JavaScript. Like, is that a problem? Because like my knowledge about calling things recursively is like, that seems like a problem, but I don't know. I guess that's okay. That's kosher in JavaScript land. It's pretty funny. I just want an infinite loop. Okay, that is just while. Man, my brain's gonna atrophy by using this. I can feel it. You gotta be careful using AI. You have to make sure you still remember to use your brain every 3 seconds. Sure. Every 3 seconds, I'm going to do this whole thing. Sure. What's the problem? Oh. I remember when I first learned about this top level async await thing and just being blown away that something can be so like difficult, like just for something as simple as like an async. Like, I'm just curious. I want to know like how do these decisions end up getting made? Like, I guess there was probably some massive compromises, but yikes. I'll write my go, thank you very much. Like, go. All right, so we got song playing. Go to the next one. Oh, wow. 1, 2, 3. Boom. That's sick. That's pretty sick. Let's see if it works. All right, so now I'm going to add a new Linux browser. Let's say this is song. This is going to be a local file. Projects. Stream index. Let's go. That's so cool. Height, turn that way down. 75? 50? That could work. Width. It's okay, I guess. Height scroll bar. All right, yeah, so let's see if I go to a next song here. Yes. Yes. Yeah, I've been really surprised by OBS. It's really, really cool. They've done a great job. Trying to figure out where to put it. All right, if I just do I could do a transparent background. Let's stick it in marquee. Is that still a thing? JavaScript marquee. Oh my god. Simple marquee? I think because they deprecated like the blink and marquee tag, I think. Yeah, let's ask. Did the marquee HTML tag get deprecated? Boo. I love the marquee. I think you can still use it regardless. Let's go. Why is there padding there? Oh no, I want it to loop. Oh, this is how you're supposed to do it. All right, no marquee. We'll use JavaScript. animate element, and I want to animate song. See if that does it. Let's go. I don't know if I really like that. I don't like that. I'm just gonna have a static one. Yeah, sure. Who cares if it gets clipped? Who cares? Sure. This is why I need my girlfriend. She's very aesthetically inclined to being a artist. I'm just the engineer that throws things together. All right, do I need to make this text a little bigger? I don't know. I guess I'm going to need to see what people say. But anyway, I'm happy with that. We're about to get a song change, I think, soon. Is it going to go? Go, 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 go. Change. 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 All right, song change. Boom. That's pretty cool. I like that. All right, so now to actual business. Because I wanted to go through some things. I've had a lot of notes, a lot of thinkies. A lot of thinking's been going on. It's pretty incredible. The state of AI right now is like popping off. It's popping. And I'm trying to just stay on top of it by talking to friends, looking at Hacker News. And it's difficult. It's difficult to keep up with everything that's going on. So what's been my strategy so far is basically just open up Hacker News every day, go through it, look at it, try to read whatever I can. I have a lot of notes that I've been taking, I'm tagging with ML search, library voice, just trying to capture everything that I can. And there's been some really cool things that I've seen, and I guess I'm going to sort of go through it. But I think the most interesting one, at least today, was ChatGPT plugins. This one's pretty big. This is building off of the work that other people have been sort of pushing forward recently. The one that I've been playing with most closely is like Langchain. And Langchain is pretty cool because it lets you sort of extend the contextual limit of ChatGPT. So what's really happening when I'm talking, so let's open up a new chat. Let's try to think about what's going on here. So I'm going to type something in, right? Tell me a joke. It's not going to tell me a good one. Maybe that's a good one. I like that one. I like that joke, so that's a good one. So when I type in tell me a joke, I'm like creating like a context for GPT to try to now guess as to what the next thing might be. So GPT, AI, it's all just probabilities. It's like really complex, really crazy probabilities. And it's trying its best to sort of complete the thought. It's kind of like the ultimate like and then improv sort of thing, because it's trained on the collectiveness of the human mind. So when I ask it to tell me a joke, it's going to try its best to complete that context, which it's been trained to know is like a chat context, people talking back and forth. And so it tells me a joke, right? Because it knows that if a person says a command like tell me a joke, it knows to respond with its best attempt to answer it. And of course, it's been trained to sort of know, right, how can I build a bomb? It knows that that is something that I shouldn't probably learn from an AI bot. And so it knows, right, it's been trained, the probabilities, the little knobs have been turned to say, nope, I'm not going to tell you how to build a bomb. So it's really cool. It's really cool because you can ask it things like, when was George Washington born? And what's interesting about asking for information and what it responds to, because it's just probabilities and it's really like asking any other person, you don't necessarily know if the information is true, right? You want to know like the references, right? Where is this information coming from? And it's possible that it gets answers wrong sometimes. So if I'm searching for George Washington, let's see, something when he was born. Show me February 22nd, 1732. February 22nd, 1732. So it did get that right. But what's interesting is if you ask it a math question, and I think GPT-4 has solved this, but I'm right now on GPT 3.5. What is, I don't know, some really large math thing. Let's see if that's right. No, that's not right. Because that 8302, yeah. So it's not really good at math, at least 3.5. And I think I can try out 4.0 here. GPT-4. And so what people have discovered through what's now been sort of called as prompt engineering is that, did they get that one right? Yeah, that looks right. So what people discovered is if you ask it to break down steps, it gets better accuracy. So if we're going to open up this and we're going to say, walk me through how you would arrive at the answer to step by step. Now the key word here is step by step. So because, like I said, GPT works with a context, it does better when the context is more, it's elaborated, right? When there's more information for it to work off. So every time it types itself out, right, every word, it steps each step one by one, and it adds to the context, right? This was the only context of the question, but as soon as it starts typing, this is actually considered as a part of the context to what is going to be outputted. So it might seem a little strange, but it's like every single, and so these inputs are broken down into what's called tokens. So while we look at things as words, the AI sort of understands things in its own way of like maybe walk is broken down into WAL. And so there's a whole idea of like an encoder, like token encoder. Yeah, GPT-3 encoder. So this is important because it is how the AI interprets things. So when you're dealing with token limits for context, like this is what you're going to need to know about. So everything's broken down into tokens. So let's see. I think that did a little better because I think it was 1380 was originally. So it got the 2 this time. 38215. Nope. So it looked like it did a little better, but still not quite. Still didn't quite get it. So yeah, GPT-4 has, I don't know if it's quite solved the problem, but it's definitely gotten a lot better at math. It is a lot better at, I guess, probably, I'm not sure about the internals yet, but probably breaking down the problem adding more context, or maybe it's possibly they just trained a lot on math problems. And what's interesting is as people have been using ChatGPT, everything that has been sent to it, that is all data that people can, or that OpenAI can now use to train. So if I said, yes, I like this, no, thumbs down, incorrect math. This isn't true. So that's interesting. So I've actually haven't played with this before, but this is helping. It's asking you, OpenAI asking you, is this answer better than this one? Neither's better. They're both wrong. So now I've given feedback. They're probably going to then use that data to then go off and train the model again to get better results for next time. So, but the thing that has really interested me here, and you can go off and train ML models. People have been doing that for a long time. But what GPT has sort of opened the door for is this idea of semantic searching being more obtainable to people that aren't as familiar with how to train an AI model or have access to GPUs, have a bunch of money to spend hosting all of this, training it. So the idea with a embedding semantic search is that you can take this information that I type that exists, maybe it's someone's text messages, Discord chat, Slack chat, PDF, literally any information. And you can ask the model to provide you with the internal representation of that information called an embedding. It's a n-dimensional vector that contains all of the different little knobs, for lack of a better word, of the probabilities. And I'm for sure butchering this. I'm not an ML expert. I've just read a lot. I've tried to understand it myself, but it's basically just an array of floating point numbers that you can then use like in Safe. Like you just save it and it's a bunch of numbers. So you take a bunch of text, put it down into numbers, and you can take all this other information, right? I might take, I don't know, I was playing around with, right? I could take some code, right? It takes some code, toss it into this embedding thing, get a bunch of floating point numbers. And so now I have two floating point numbers. Now there's this thing called a cosine similarity check, where it will try to measure the similarity between two non-zero vectors. And right, those two things that I got back from the generated embedding, the two embeddings, I can compare those using a cosine similarity distance function. And if they are close based off of some defined amount, you can say that those things are probably semantically pretty similar. So I could ask a question of, so I've been taking notes, right? I've been taking notes. I write down information. I can generate embeddings for all my notes. And so I can ask a question of my notes. What season are cherries ready to harvest? So that question generates embedding, vector, boom, that exists. Now, beforehand, because I have a bunch of notes, I have a lot of notes, and it takes time to generate these embeddings. Beforehand, I generate as many embeddings as I can. And there's a limit to the size of information that you can have when generating these embeddings because GPT has a limited context. And let's search for that. What is the size of GPT's, or what is the token limit for ChatGPT? And GPT-4 has made this larger. Token limits. GPT, 4,096 token limit. GPT-4, 8K, 8K, 32,000. So that's huge, right, compared to this one. So that's currently right now what's generally available, and they're rolling out API access to GPT-4, which will greatly increase it. So you can put 4,096 tokens. Now, I might have a note that's really huge, right, all of this information. So how do I stick that into, right, a blog post might be longer, a PDF might be longer, a whole book. So you have to break those up into little chunks, right? Little chunks that fit into this 4,096 token limit. And once you've broken those chunks up, you can then generate an embedding. So now you have that n-dimensional vector. I forget what the number of, like, what n is. There definitely has that defined for GPT. I have that somewhere in code. But yeah, you have that vector, you have your question, and now you can take your question and then search using cosine similarity across all of those different vectors. And what you're looking for is the ones that are most similar, the number that comes back from that distance function that's as small as possible, and that's how you rank them, right? Now, the similarity is only as good as the model, right? The numbers that you get back and how it understands semantic relationships. So, right, my question that I posed was what season do cherries harvested? So in my notes, if I said somewhere about cherries, right, it could be the song Cherry Pie. It could be actually talking about cherries. It could be Cherry MX keycaps for my keyboard. Depending on the model, it might mistakenly say that that is something that's semantically important as it relates to the question. Now, in that initial question, there is also a mention of season. It is a mention of harvesting. So it's possible that the model, in its like weird way of representing information through all those seemingly random like floating point numbers, it knows somewhere in there that it's like fruit, right? Like there's a little number in there that has some idea of like what a fruit is. So by asking the question like that for cherries, it's going to rule out Cherry Pie because that's a song, right? It knows what songs are, what it's trained on that. It's going to rule out Cherry MX keycaps because it knows that those are keycaps. Now, of course, they only know about that because they would only know about that if they scraped the right data, right? They scraped the Cherry MX site, they've scraped song information. And so those distance functions should be theoretically further away, or the resulting check of the distance function is a lot larger. And so that small number should come from me writing about cherries, having written about cherries, and that's what I should find, theoretically. So where you sort of get caught up is when you think about all of the different information, right? If I write a lot about cherries, the fruit, then this embedding search, depending on the quality and its ability to write the number of dimensions that I'm searching for and with, it might not be smart enough to differentiate like season and fruit and cherry, all those different, because that's a complex relationship, like those three ideas. So the more dimensions you have on that embedding vector, the better a semantic search will be, but it's also costly, right? To generate that, it takes a lot of power. It might cost more. So there's different techniques that people have been using to sort of improve the performance of that embedding search, or maybe even not even using that embedding search at all, right? Shrinking down all this information into something that you could recursively run GPT queries on. So, and just a note on that, like an embedding search is fast, it's quick, and there's a lot of people that have cropped up. There's like, what do we got here? We got, oh my gosh, go away. Let's see, Langchain has a whole thing here, like Pinecone, vector stores. Thought they had a list. Indexes. Nope. Yeah, maybe just look at Pinecone. Yeah, so there's Atlas DB. And so vector stores is a place where you store your embedding, right? Your vector, your n-dimensional vector. And there's a lot that have cropped up because it's important to get this right. If you have a lot of data, you want it to go somewhere, so where are you going to put it? You'll store your embeddings in a vector store. So there's like Atlas DB, there's Pinecone, there is Deep Lake. What's the other one? Weaviate. Elastic Vector Search, is that like, I wonder if that's AWS. Oh no, Elasticsearch. Yeah, and so these whole dedicated services have sprouted up because it is difficult to store and search these vectors because they take up a lot of data, a lot of storage, a lot of memory. There's different techniques for indexing them, right? So a database's performance is often limited by its ability to index data. So these vector stores employ a wide variety of different vector storage techniques. And I was reading a really nice blog post about that from, I believe it was Pinecone. Composite indexes. So this was a really interesting read. It was talking about all the different techniques of storing it, and a composite index is ultimately the most effective way to store it, and it is composited of these different techniques for storing information, and it will do things like compress the vector so that it's smaller, so it doesn't use as much memory. When you load it into the memory of the database, it will do a whole bunch of other things that I quite honestly am not an expert of, so I don't really know. I can't speak to it, but there is a good blog post out there by Pinecone that you should check out. And yeah, that's about storage. Oh yeah, so there's vector stores that have cropped up, and they're really nice to store information. But what I have been interested in is the fact that Postgres has a tool called PG Vector. And PG Vector is something that you can load directly into your database and then use this handy little operator that they expose for cosine similarity. And they also have some techniques for indexing. They don't have like a composite one. You can only really use like one of the different vector or the embedding storage techniques. So for small data sets, this is going to be pretty okay. Like you're going to do pretty well. And there is a really nice blog post by who? Supabase. Supabase has a nice one on Postgres embeddings. So this is a whole walkthrough that shows you how to use Supabase to create a table in your database, create a function that lets you search through your embeddings, and then some code for generating, storing it using OpenAI to generate the embeddings. And then, you're on your way. So you might be careful though, because if you want to start using this, everything in AI is moving so fast that some of these models might be out of date. So I would just check to make sure that these are the most up-to-date recommended ones. And actually, I think you might be able to use GPT now. I could be wrong about that, but maybe it's still text embedding Ada 2 is the model of choice here. That was last year. Let's see. OpenAI text embeddings API. Still looks like they recommend it. It's definitely cheap. I guess maybe there's, oh no, it still has the best performance. Yeah, so that still looks like the one. So cool. So yeah, definitely recommend you check out this one if you're interested in building this yourself. It's super easy. It's in Postgres. You just need to make sure that you have a database that has PG Vector set up in it. So yeah, that's how you could build your own thing. And so even before that though, like if you want to get started playing with AI, highly recommend Langchain. It is really easy to start getting set up. And the thing that I'm really excited about is the idea of agents. So like I said, in GPT, you're ultimately limited by the context, right? Whatever you're operating in, whatever your chat is, like that is what you have. So, and also you can ask it, when have you collected data until? So GPT is, so there is a cutoff. So September 2021. So at least the publicly available thing that you can access. That is when data is trained to. And there's kind of this mad rush in the community to train on like more recent data, more relevant data. And there is Llama, Facebook, and there's, so this was something that got released by Facebook, Llama. And with Llama, it was a big deal because it was released as open source. So you can play with this model. You can train your model yourself. GPT is not open source. You can't train it yourself. But it comes with a stipulation because of the license, you can't be building a business on top of it. So it's really kind of introduced as a research sort of thing, something for people to play with. And so since then, there's been Alpaca, which is, I believe, an extension off of Llama. Yeah. So it's a fine tune from Meta's Llama, and they've trained it. And I forget exactly what was special about Alpaca. I think they added literally the chat functionality that we've become accustomed to with ChatGPT, which Llama did not previously have. So it's the instruction following. So if you tell it to write me code, right now, Alpaca knows how to do that. So if you are wanting to play locally and train your own thing, there's a lot of research around Alpaca. And I'm sure if you go to GitHub and search for Alpaca, you'll see projects popping up. There's also Hacker News has had a lot of people writing about stuff. We've had a friend that we've known for a while who wrote and had like a top Hacker News post about fine-tuning Alpaca Llama. So hard to keep track. It's somewhere in my notes. It was pretty recent. Maybe if I search like fine-tune Llama. Running Llama. Oh yeah, this one was pretty funny. So someone's fine-tuned Llama to speak like Homer Simpson. So there's a Kaggle dataset with Simpson script lines. So it just fed those in, and now it can talk like Homer Simpson. And so Llama's performance is not as good as GPT, and it's probably not going to be because, or at least in the short term, because all the hype is on ChatGPT. People are entering in messages, they're playing with it a lot. And so every time, like I showed you, like you can gather data from what people like or don't like and then give feedback to. So that really helps because your ML model is going to always be limited by the data that you have. And your ability to then subsequently train. So that production readiness of a model. And it seems like OpenAI has definitely like the advantage there so far. And Facebook has a lot of data, right? I mean, it has all the messages, but it is also a large company. Large companies move slower. They are the right hand talking to the left. They can't quite figure it out. So there's going to be some limiting factors for the big existing FANG companies to sort of catch up, I think. And Microsoft tried releasing Bing. I don't know if Bing Chat is available, but the new Bing. Start chatting. Log in with Microsoft. My favorite. Oh my gosh, looks good. Don't show me again. Show me the chat. No thanks. I don't even bother. My fonts are broken on that site. Oh my god. Oh. Just show me. Chat. Okay, yeah. Okay, so it was. Oh my god. So you have to use it. Oh god, that's so painful. So yeah, I'm probably not going to be playing with Edge. Maybe I should. I should probably know. But so this Bing chat was interesting because, and it doesn't show it here in the demo, but the thing that is most important to me as someone that's skeptical about the information coming back from a platform like this is I honestly only care about the references. I would like to see sort of a summary of data, but ultimately I want to be able to go into the source of information where it's based its reasoning off of and look at it myself. So Bing was cool because it had that. You could ask it questions, and because it's already an existing search engine, it could also show you links to pages. And I'm assuming that's going to be the trend of Google as well, since they have all that data. And that's going to be something that people are just going to have to do, right? You can't trust, people are not going to trust, or it could be really dangerous to just spit out information back at someone. And then you have hallucinations, right, where it just makes up information that's really dangerous. So people with existing chats are going to have to be careful, and they're going to have to get it right. I'm probably going to have to just play with this Bing chat, unfortunately. I do have a Windows computer, so that's at least good. Ugh. But anyway, what was I saying? So yeah, so agents are building off the same idea of a chatbot is only as good as the data that it has in its context, right? It's only as good as the data that you can see with your eyes, right, available to the chat context. So what an agent can do is it can go off on and perform operations. So you could ask it a question, and then it can perform a Google search. And the Google search could be, so if the question is, I need to find out Leonardo DiCaprio's girlfriend, age, raised to the 0.43 power, you can search for that name on Google, and Langchain is capable of sort of chaining prompts together. So all it's doing under the hood is kind of like hooking up the output of GPT to like a program. So it knows that if you ask it about like who Leo's girlfriend is, that it can just go off and do the Google search, get the results, put it back in the prompt. So more or less what it's doing is like Leo, or we can actually just replicate what this thing is doing. So it's quite literally taking this, going to Google, taking those results. So like, oh my gosh, taking the results, putting them in here, and it's like, here are some Google results. Right, and so GPT is capable of knowing, and then how old is Leonardo DiCaprio's girlfriend? So there you go. It just does simple math, and it's good at that. It's good at simple math. So it can figure that out. Right? Is that right? Yeah, that's right. So yeah, it can figure out basic math, so it can crush that. And oh wait, is it wrong? Actually, it should be 25. Oh. Oh my gosh, I'm so bad at math. No, wait, no. Oh, this one got it wrong. Oh, that's interesting. Yeah, I don't know. Unless maybe the information I sent was wrong. Anyway, still capable of hallucinating. So it's still cool, but you still got to be careful. But what is cool, in my opinion, is that it could give you this result based off of, and then include it like based off of this URL, right? It can include the URL, show you in the results. So if you wanted to verify, you can. Now, these can perform operations. It can go off and do something. It could schedule a calendar event. It can do anything, right? You just connect any code to this and it can go and run it. Now, again, you have to be careful. You should be careful when using this. I would not trust it with my bank account at the moment. If it was like, send this amount of money to this other person, I would warn you from doing that. That is probably going to cause you to lose a bunch of money. Or maybe you could steal a bunch of money because someone, or the AI is smart enough to know how to make tax loopholes or something. I don't know. It's going to be crazy. But anyway, context is really important. Langchain agents help you a lot with this. Now, Langchain is really cool for getting started off. There's a lot of examples. There's also a Discord that you can join, ask questions, a lot of really cool people on there. Now, for me, where my head is at, the things that interest me, because I have I have all these crazy notes, I started recording my voice. I started recording my voice and just talking about ideas. I want to be able to search that. And not just search that, I also want to see summaries, right? I want to categorize my information. I want to sort of play with it, right? What is going on in my mind? And so what I've sort of been led to is looking at another project called, it's kind of in between a brand change, but Llama Index. Now, Llama Index interacts with Langchain. You can use them sort of together. They're built to sort of be integrated. But there's a really powerful idea in here called composability. Now, when I write code, I love composability. I try to write my code so it's composable as possible. A blog post writing about composability. And it gives you a really powerful thing with AI because you can ask it to go to different data sources and go and just look at the content. And from that content, it can generate an index for it. So it could be like an embedding, right? Like I was explaining, an embedding index where it just tries to roughly approximate semantic relationships in that information. You can also ask it to summarize that information. So, right, you have all of this information, like pages and pages, PDFs, and you can go through, and there's an idea in Langchain called refine, which I thought was really cool. Yeah, so you can combine documents using using different techniques, and all that it's doing is taking a bunch of text and iteratively asking, or maybe even recursively asking with MapReduce, or I don't know how those stuff. I was just looking at refine, but it can go through iteratively compress that information. So AI is really good at compressing information. It can find categories, shrink them together. There's a model that has been trained, BERT Summarizer. So this model has been really fine-tuned, and it's better at categorization of information. And it's really good at taking a bunch of information and compressing it down so that the meaning is preserved, right? What is being talked about, but the details are kind of glossed over, right? The more fine-grained, detailed stuff. So what you're left with is kind of compressed information. Now it is lossy. It's like lossy compression. But just like with a song, right? If you compress the audio of a song, you can still hear it, right? And similar for a summary, you can still understand what's going on. And it's not going to be perfect, but it's an index into all of that information if you've stored your information in a somewhat organized way, right? So for my cherry example, if all my information about food is a super category to the subcategory of fruits, and then from that, cherries, information about cherries. So I can find information about cherries easily by going through those indices. So, right, so directories structured, they represent structured information. We tend to use directories, folders on our computer to store information that's relevant to each other inside of there so we can navigate easily. So you can do that with Llama Index and take all the information in a folder, compress it using that lossy summarization, embedding compression, information compression, and you can get these different documents. And from those documents, you can create an index. And an index can take different forms. There's a list index. The one that I've been playing with is the tree index, where you can jump from summary to summary of category. So for the food category, that could be something like food is something that humans eat. food has different types of food, such as fruits, vegetables, meat, eggs, or dairy. And now if I ask a question about something relating to food, it can do an initial pass over all of these different types of higher level ideas like food. I like writing about food, programming, right? So we can know that it's closer to the food thing than the programming one. So we can go deeper into that food one. Now from there, if I'm asking a question about cherry, the category of fruit is going to pertain more than the category of vegetable. So it's then going to go into that index. And so these trees you can navigate through, and you can, right, you set a summary like I was talking about, like with the food one. And so when you ask that question, you zero in on what's actually going on, right? You start with the query, you go down to the deeper one, and then from that specific context, you can put that, right? You take the context, you put that into the context of GPT. Now it can answer a question more confidently, more accurately, more reliably, right? You get the information that you actually want. Now, this is difficult. It's difficult because what it requires you to do is have structured information. Now, what I've been thinking about is like, where does structured information exist? And you see this in books, right? Books have table of contents. In each section on that table of contents, that is a pointer, right? It points to data within that chapter, within that section. And you can just summarize all of that information from that section. And then that forms your tree in the like searching, right? The searching tree index form. So yeah, so something like a book is really good for an application like this. With my notes, there is a graph structure because I can tag things with each other. That's right. Omnivore is like my reading app. So I could ask a question like from the things that I've read, right? And so Omnivore, I could set the summary for it. It's like Omnivore is an app that is a read it later app that contains things that the author has saved to read later. So my question, if I were to say, based off the things that I've written, what do I find interesting about food? Now, food is a tag. It's a category of things that I'll label. And so it can pivot. My question would start out with all of these different high-level nodes, and it would know that the thing that is most likely what I'm asking about is related to whatever's inside of Omnivore. So we'll go into that, right? And then once we're inside of Omnivore, once we're inside of there, then you can say, based off what I read, how do I feel about gardening? Right? So now all of the things that relate to gardening, I can pull up. And so now if I had scraped this web page, whatever's inside of there, that can be added into the context, right? And that web page might be large. And so again, I could be summarizing it. So hopefully you see the idea that I'm building here. It's just like AI is really good at compressing information. If you can store it into a tree structure that you can search, then you can find information that you want and ask complicated questions. Now, information is not always a tree. It's more like a graph, right? We make connections with each other. But for like starting out, it's like pretty easy to sort of think about and build around the idea of information just stored as a categorical tree. And over time, I wanted to sort of learn about graph databases. I'm not too familiar with them, to sort of represent this data and be able to sort of jump between things. Because if I'm talking about gardening from things that I've saved, there might be a higher level idea here than I do have, like just this bigger idea of around gardening, around planning, that it would be nice to be able to connect, right? Be able to have that context inside of there. So there's like this, so the thing that our company has been pivoting from, so we were a security company trying to sell stuff, hadn't really been working. So what we're pivoting into is the AI space. And what just excites me so much is that I've literally been trying to build something like this based off my notes, based off things that I've been reading for so long. And now it's like possible. I see how that can be. And so we've been playing with things like recording our voice, splitting it out based off of what people are saying. What the heck is that technique called? It's like dia something. Dia. Split. I don't know. But anyway, there's some technique, some type of model name where you can split like a recording into the different parts that people are talking. So you can do speaker identification. You get a transcript of what everyone's saying. Now that's something that you can search, right? You have the transcript of all these people, and you can search through things that people have said. So what has Chris said, right? You could ask that question. What in this meeting, what did Chris talk about? And then you can get an itemized list of everything that I talked about. So that's something that's been interesting on my mind. And so that's what we've been starting to build. The current work in progress name is LunaMind. We were LunaSec and now we're LunaMind. And good SEO. We checked out the SEO on that. So yeah, so that's what we're going to be building. And I've been working on some code that has like this pipeline for capturing information, normalizing it, and then doing things like summarizing it. And yeah, we're just going to see how far we go. The dream that I have is that I can open up my phone. There is 3 simple buttons or 3 simple ways of inputting information, right? My voice, text, or like an image, maybe eventually even a video. But through those simple things, you can capture so much of the things that you do, right? If you can just sort of speak to yourself, right? What's on your mind, that can be transcribed, that can be saved, that can be summarized, that can be automatically categorized. And now when you go to look for that information again, if you could search it, what were my ideas that I had about art? What have I thought about for art? Imagine if you could like literally come back, have something tucked to you based off the notes that you've taken, images you've taken that has been tagged, right? You took an image of like a Van Gogh painting. And it's like, hey, you've taken a picture of Van Gogh painting. Like, do you want to see what that looks like in your style, right? This is like the future crazy AI world of integrating stable diffusion with the images you've taken, right? Like possibilities are limitless here. And the thing that's going to be limiting is your ability to write and deploy code. Because right now, like there's no like Heroku's dead. Salesforce bought it, ran into the ground. There's like Render, which is trying to fill in that space, or Fly.io. But this is another sort of place that I've been thinking about a lot is like, how can you make writing code like just so and deploying code so easy, so trivial, so that people can take advantage of using Langchain agents or writing their little passes, connecting things together, right? Those little small pipes, that last mile of code that you need to make something really go. So anyway, that's really all I want to say for right now. I don't know if people were talking at all. No. But anyway, yeah. I'm going to get back to coding, but it's the future of AI. We're here. We're going to do it. We're going to make it happen. So I'll see y'all.